Sa video natin ngayon, we will try to solve a 3 moving loads problem. So, let's check PSAD only. Deselect all. Check natin yung moving loads lang. Ito. Then, generate exam. So, let's answer situation 1. By the way, this problem comes from matalino.com. A truck and trailer combination crossing a 12 meter span daw has axle loads of 10, 20, and 30 kilonewtons separated respectively by distances of 3 and 5 meters. Now, what we want to compute is the maximum moment and maximum shear developed in the span. So, draw natin yan to scale. And then, meron tayong choices para sa situation 1. So, show natin yung grid lines. Ayan. Then, ito yung moving loads natin, 10, 20, and 30. So, the distance between the 10 kilonewton load and 20 kilonewton load is 3 meters. So, 1, 2, 3. Ayan. Then, 5 meters from the 20 kilonewton load, we have our 30 kilonewton load. So, 1, 2, 3, 4, 5. Ayan. So, again, this is 3 meters. Ito naman 5 meters. Then yung span natin is 12 meters. Ayan. So itong figure natin, naka-scale na yan. So once we add the loads, then we can automatically see if some of the loads would be outside the span or kung pasok lang lahat. So label natin yan as point A, ito naman point B. Then this is RA. RA saka RB. Ayan. So, for the first question, we have to compute the maximum moment. Now, to do that, we will first solve the resultant of the 3 forces. Ayan, parallel force system lang yan. So, sabihin lang natin, ito yung reference axis. Then, solve natin yung barred X. So, the resultant of the following loads would be 30 plus 20 plus 10. So, that would be 60 kilonewtons times barred X equals, ito yung reference axis, so 10 times 0, then plus 20 multiplied by 3 meters going to the reference axis. Then we have 30 kilonewtons to the reference axis. The distance is 8 meters. Ayan. So, masosolve natin yung barred X. We have 20 times 3 plus 30 times 8 divided by 60. Ayan. So, we have 5 meters barred X. So, yung 5 meters from the left is exactly located dito. 3, 4, 5. Ito. So, this is the location of the resultant. Barred X equals 5 meters. Ayan. Then, again, our resultant load is 60 kilonewtons. Ayan. So, yung first natin gagawin is we will solve the maximum moment under the 10 kilonewton load. The next, under the 20 kN load. Then, finally, the 30 kN load. So, meron pala tayong tatlong possible maximum moments. But we will choose the largest one. So, copy lang natin yan. Then, for the first one, maximum moment under the 10 kN load. Or, ito na lang, Mmax at 10 kilonewton load. Ayan. So, yung gagawin natin is, ito yung resultant, ito naman yung 10 kN load. We will find the center of the two loads. So, the center would be ito. Ayan, 60 kN going to the 10 kN load. So, this center point, ayan, would have a distance of 2.5 meters going to the 10 kN load and the 60 kN load. So, yung center point na yan, ilalagay natin yan sa midspan. So, yung midspan ng beam is andito. Ayan, ito yung center line. C sub L. Copy na lang natin yan for the remaining problems. So, yung green line na yan, ilalagay natin sa center line. Ayan. So, ito yung resulting figure. Then, after which, we want to compute the maximum moment under the 10 kN load. To do that, we just want to solve RA. Then, we take its moment about the 10 kilonewton load. So, we need the following moment arm. Ayan, this moment arm. Now, this moment arm is just going to be, di ba, yung span ng beam natin is 12 meters. Ayan. So, kalahati niyan, going to the center line, is only 6 meters. 6 meters, saka ito rin. 6 meters din yan. Lagay na lang din natin na dito. Tig 6M yung dalawa. Ayan. So, to solve RA, since lahat ng loads natin pasok lang sa span ng beam, again, scale natin yan. So, yung 30 kN is pasok lang. Ayan. Hindi siya nag-exceed sa point B. But, in order to check, if hindi nakascale yung drawing mo, then we will use the distances. So, bali, ano yung gagawin? Diba, this is 2.5 meters. Ito, 2.5. 5 plus 3 is 8 meters. So, meron din tayong distance dyan. Ito. Bali, yung distance na yan would be the remaining distance, 3 meters. Ayan. A total of 8 meters. Now, from the center line, this is 2.5 plus 3. So, magiging 5.5 yung total distance. Now, 5.5 is lesser than 6 meters. So, kaya, we can verify na yung 30 kN is pasok lang talaga sa span AB. Ayan. So, ngayon, we will solve RA. Summation of moments about B tayo equal 0. Then, to simplify our calculations, let's just use the resultant sa calculation natin. Let's avoid using the individual loads 10, 20, and 30 since mas mahaba yung solution. Anyway, all of these loads are replaced by this resultant force. Ayan. So, moment tayo sa B, we have RA multiplied by 12 meters. Ayan. Then, minus 60. Counterclockwise rotation about point B. Ayan. Then, ano yung moment arm na yan? Diba, this moment arm would be equal to 6 meters, tas ibabawas natin yung 2.5 meters. Ito. So, we can get the remaining distance. 6 minus 2.5. Ayan. Then, equate natin yan to 0. We can solve RA. So, RA equals 60 times 6 minus 2.5 divided by 12. So, we have 17.5. This is kilonewtons. So, ngayon, moment tayo sa 10 kN load. M max under the 10 kilonewton load. We need to find this distance. Ayan. To find this distance, di ba, 6 meters yan. So, essentially, 6. Then, ibabawas natin yung 2.5 meters. Ayan. So, this is, again, 17.5 kilonewtons. Then, this distance is 6 minus 2.5. Ayan. So, 17.5 times 6 minus 2.5 equals, bale, same moment arm pa rin. Ito, gagawin nating 17.5. Ayan. So, we would get 61.25. This is kilonewton meter. Ayan. So, again I am emphasizing this solution since makikita nyo yung pattern dyan. Ito, 6 minus 2.5, yung moment arm going to the 10 kN load is also 6 minus 2.5. You can use this concept to simplify your calculations. Bale, yung moment arm ng 60 patungo sa other end, yung point B, equal lang sa moment arm ng RA patungo sa 10 kN load. So, we can verify that sa next calculation natin. Ito yung maximum moment under the 10 kN load. But, hindi pa tayo sure if ito yung answer natin. Since we also have to check kung ano yung maximum moment under the 20 and 30 kilonewton loads. So, if we will check dito sa choices, merong 61.25. Ayan. But, possibly, trap choice lang yan. Hindi pa yan yung actual na sagot natin. So, we will check sa ano naman, 20 kN load. Ano yung maximum moment. So, copy natin ulit. Then, we will now consider the 20 kN load. Ayan. So, between the resultant and the 20 kN load, we have this point. Ayan. Bale, ito. Yung distance na yan is 5 minus 3. So, di ba yung natira is, ano lang, 2 meters. So, yung gitna ng dalawang points, yung 20 saka 60, would be 1 meter. Ayan, tig 1 meter. 1M ito rin. Again, naka-scale yan. So, we can just check the grid lines. So, ito yung center point ng dalawang loads. Ilalagay natin yan sa midspan. So, ito yung mangyayari. Yung green line, ilalagay natin sa center line ng beam. Ayan, ito na yung figure. So, once we draw the figure, we can now solve RA or RB. Depende na lang kung ano yung preference mo. Ako, yung isosolve ko na lang is RA. Anyway, if I take moments about the 20 kN load, I will include the 10 kN load. If from the right naman, I will include the 30 kN load. So, yung length ng solution, same lang. Either ends. So, again, gagawin ko is I will take moments about B equal to 0. Then, as you can see, lahat ng loads pasok sa span. Ayan, you can verify this by using the distances. So, ito, 1 meter lang yan. 1 meter. Again, 6 meters yan. So, 6 meters. Ito, 3 plus 1, 4 meters. Lesser than 6. So, pasok yung 10 kN load. Then, for the 30 kN load naman, we have, ito, 1 meter yan. Tas, ano yung remaining distance? Ito. Diba, this remaining distance is 3 meters. 5 plus 3 meters. Ayan. So, kapag 3 meters yan, 3 plus 1 is equal to 4, lesser than 6. So, pasok din yung 30 kN load. Ayan. Again, summation of moments about point B, we have RA multiplied by a distance of 12 meters. Then, let's just use the resultant since pasok naman lahat ng loads. Minus 60. Then, our moment arm going to point B, this one. Ano yan? 6 minus 1 meter. Ayan. Or this is 5 meters. Ayan. So, 60 times 5. Equate natin to 0. So, solving RA, we have 60 times 5 divided by 12. Ayan. So, we have 25 kilonewtons. So, to solve the maximum moment under the 20 kN load, we have M max 20. Ayan. We start with RA. So, again, this is 25 kilonewtons. Then, yung moment arm niya going to the 20 kN load is equal to 5 meters. Diba, sinabi ko kanina kung ano yung moment arm ng resultant patungo sa nearest support, yan din yung moment arm ng left support going to the load of interest. So, M max 20 again is 25 kN times this distance. Ayan, 5 meters yan. 6 meters minus ito, 1 meter. 25 times 5. Ayan. And then, minus yung 10 kN load. Dito kasi natin ikakat yung beam. Ayan. To obtain the moment here, exactly at this point. So, magmamatter yung 10 kN load. Bale, this will cause a counterclockwise moment about the 20 kN load. So, minus 10. Then, the moment arm going to the 20 kN load is 3 meters. Ayan. So, M max under the 20 kN load is 25 times 5. Then, minus 10 multiplied by 3. So, we have 95 kilonewton meter. Ayan. So, ito yung Mmax under the 20 kN load. Andun din yan sa choices. Ayan, we have here 95. So, finally, to verify our answer, since meron kasing 106.67 saka 104.17, naturally, ito yung lalabas, baka ito yung lalabas if we solve the maximum moment under the 30 kN load. But hindi natin alam kung ano talaga yung maximum. So, we cannot assume just by using the choices. Isosolve talaga natin. So, for the last one, again, ilalagay ko yan. Yung distance na yan is 3 meters yan. Going to the 30 kN load. Ayan. So, yung gitna ng 30 kN load and the resultant is anditong banda. Andyan. So, yung distance na yan, 1.5 meters. Saka ito rin, 1.5 meters. So, we project a vertical line from the center point. Ayan. Then, ito yung ilalagay natin sa midspan ng beam. So, copy natin yan. Tapos, ilalagay natin sa center line. Ayan. So, notice na since nakascale yung figure natin, yung 10 kN is actually lalabas siya sa span ng beam. Ayan, yung 10 kN, lagpas na sa point A. Now, to verify that distance, then we will check this one. Ito 5 meters yan, di ba? Going to the 60 kN load. Tas ito naman, 1.5 meters. 5 plus 1.5 is 6.5. 6.5 is greater than 6 meters. So, dyan natin ma-verify na yung 10 kN load is outside the span talaga. Ayan. So, merong excess distance dyan na 0.5 meters. Ito. 0.5 meters. So, hindi na yan kasali sa calculation natin. Ayan. Now, if merong load na hindi na within the span, again, we cannot use the resultant force anymore. And then, this configuration will not cause the maximum moment. You can check our previous video with the two moving loads kung ano yung gagawin if merong load na lalagpas sa span. Essentially, yung mangyayari is 3 moving loads yung problem. Kapag merong load na lalabas sa span, then we will reduce the problem into a 2 moving loads problem. Ayan. So, sir, ano yung ibig sabihin ng i-reduce natin into a 2 moving loads problem? Since yung 10, hindi na siya pasok, ayan, outside the span na siya, then we will just consider the following loads. Yung 20 kN saka 30 kN load. Then, we will compute the maximum moment under the 30 kN load. Diba, yung 30 kN load, this is the larger load between the two, yung 20 saka 30. So, I hope agree lang na once we reduce the problem into a 2 moving loads problem, then we can just readily apply the formula PL minus PSD squared divided by 4PL. Bali, yung moving loads na i-consider natin, itong dalawa na lang. Ayan, yung 20 saka 30. So, ano yung distance separating the two loads? Diba, ito 5 meters. Apply na lang natin yung formula for the maximum moment considering two moving loads. Ayan, under the larger load. So, again, PL minus PSD squared divided by 4PL. Ayan, diba, pray lang, pasado to, 4 PRC license. Ayan. Now, P is equal to the sum of the two loads. 30 plus 20 is equal to 50. Ayan, 50 kilonewtons. The length naman is equal to 12 meters. Yung length ng span yan. Then, P sub S is the value of the smaller load. The smaller load is 20 kilonewtons. Ayan. You may also solve this manually using two moving loads. Using two moving loads, ito na lang yung i-consider mo. Yung 20 kN saka 5 meters. Bale, ito na lang. Yan, you can reduce the problem into two moving loads. Then, if you want, pwede mong i-calculate mano-mano. But, you will have to solve a new resultant location. Ayan, since dalawang loads na lang, hindi na ito yung magiging location ng resultant. So, you can apply Varignon's theorem. Ayan, I will just leave this as a practice problem. You can solve this one ulit. Ayan. Considering only the two loads. Since again, yung 10, lagpas na siya sa span. Anyway, yung makukuha mo, if this is your moving load, crossing a span of 12 meters, ito yung makukuha mong maximum moment. Ayan. So, P sub S equals 20 kilonewtons, the value of the smaller load. Then, D is the distance between the wheel loads. So, 5 meters yan. Ito. So, we have here 50 times 12. Then, minus 20 times 5 meters. Then, squared divided by 4 PL. So, 4 times 50 times 12. Ayan. Equals 50 times 12 minus 20 times 5 squared. Then, over 4 times 50 times 12. Ayan. We would get 104.17 kilonewton meter. Ayan. So, sa lahat ng moments na nakalculate natin, 61.25, 95, and ito, 104.17, ito yung pinakamalaki. So, this will govern. This is our answer for the maximum moment. Ayan. Now, let me clarify lang. We were able to apply this formula since we wanted the maximum moment under the 30 kN load. Once we have reduced the problem into a 2 moving loads problem, yung 30 kasi yung mas malaki na load. So, that's why we could apply the general formula. But what if magkabaliktad yung 20 saka 30? Then, you cannot apply the formula. Bali, yung mangyayari dyan, if for example lang, yung 10 kN is nasa labas ng span, but then we want the maximum moment under the 20 kN load, then we have to solve manually talaga. We solve the maximum moment under the 20 kN load by solving a new location of the resultant and using that location to determine the maximum moment. Now, for the maximum shear naman, again, for shear, medyo madali lang yung process. Kasi yung gagawin, ilalagay lang natin yung farthest extreme load exactly over the support. So, check natin. Dito sa figure, the distance going to the left extreme load or extreme load, ibig sabihin yan, pinakadulo, is 5 meters. Then, going to the 30 kilonewton load naman, we only have a distance of 3 meters. So, di ba, mas malapit yung 60 kN load dito sa 30 kilonewton load. So, gagawin natin, ilalagay natin yung 30 kilonewton load doon sa right support. Kasi ito kasi yung nasa right extreme end. So, copy natin yan. Then, for the maximum shear, ilalagay natin yan at point B. Exactly at point B. Ayan. Move lang natin. Ayan. So, dito sa shear, you can directly check kung pasok ba siya sa span. 5 plus 3 meters is 8. Lesser than 12 meters yan. So, lahat ng loads, pasok sa span. You will just check the distance between wheel loads, yung total distance. So, ngayon, isosolve natin yung RB. Ito kasi yung load nearest to the resultant, nilagay natin at point B. So, yung RB yung isosolve natin. Yan yung magiging value ng maximum shear. So, summation of moments tayo about point A equal to 0. Then, yung gagawin na lang natin is we will just use the resultant force. Ayan. So, RB will cause a counterclockwise rotation about A. Negative RB times 12. Then, this load, the resultant load, will cause a clockwise rotation about A. Then, ano yung moment arm natin? Di ba 12 meters yung buong distance na yan? Ito naman, 3 meters from the right. So, this moment arm is going to be 12 minus 3. Ayan. 12 minus 3 is equal to 9 meters. Ayan, 60 times 9. Then, equate to 0. So, we have here minus 12x. Ano na lang? 60 times 9. Move this to the other side of the equation. Then, divide natin by 12. Ayan. So, the maximum shear which is RB, is 45 kilonewtons. Ayan. So, we denote this as Vmax. Maximum shear. Ayan. So, sagutan natin yung questions. Maximum moment, yung nakuha natin is 104.17. Tapos, sa maximum shear naman, we have 45 kilonewtons. So, click on Submit Answers. Ayan, tama yung dalawang sagot natin. 104.17 and 45 kilonewtons. Sige, so ito lang yung process when solving moving loads problems. Kapag 3 moving loads, essentially, the same process pa rin. Hanapin mo yung gitna ng load of interest and the resultant force, then ilagay mo sa center line. But again, merong cases na merong load na lalagpas sa span. Kapag lalagpas sa span, then we discount this load since this will not affect the reaction at A. So, it will not affect the moment under the 30 kilonewton load. Now, yung usual mistake is, once na-draw na yung figure, nagmo-moment pa rin yung students going to the 30 kilonewton load. But again, this will not cause the maximum moment. Since yung 10 kN, nasa labas na, we cannot use the resultant force. Mag-iiba na kasi yung resultant. Bali, itong dalawang loads na lang, 20 and 30, yung resultant niya magiging 50 kN na lang. Then, you will reduce the problem into a 2 moving loads problem. Hindi na siya 3 moving loads pag merong load na lagpas sa span. We will keep on repeating that since ito yung important consideration talaga sa 3 moving loads problems. So, I hope nakatulong yung lecture natin ngayon. And then, I will post the additional problems if you want to practice dito sa website natin. So, click mo lang yan. PSAD, then Mechanics of Deformable Bodies. Tapos, merong moving loads dyan. Meron na tayong dalawang problems, essentially. Ito yung problem 1. Then, we have our problem 2. Ilalagay ko yung problem na to sa problem 4. Then, for problem 3, I will leave it as a practice problem.